From the surface of the Sun to the surface of the Earth, a particle of light takes only 8 minutes to travel the intervening 150 million kilometers. But from the core of the Sun to its surface, a distance of 700,000 kilometers, it could take the light up to 100,000 years to escape. The key piece of information we are missing here is that the Sun is very dense, as in there are lots and lots of particles squashed in really close to one another. Within the core of the Sun is a process called nuclear fusion, where hydrogen, the lightest element in the universe, is being turned into helium, the second lightest element in the universe. The act of squashing two hydrogen atoms into a helium atom produces particles of light, otherwise known as photons, which is why the Sun appears to shine so brightly. When a photon is released, it immediately travels at its fastest speed, conveniently called the speed of light, but can't go very far inside the Sun until it bumps into another particle. This particle sends the photon off in a completely random direction, where it will very quickly bump into another particle. This way of moving is known as a random walk. I have a maze activity here which demonstrates a random walk that you can play yourself at home. Don't worry, it won't take you 100,000 years to escape this maze. Probably. You can find a link to the free printable version of this maze in the description below. This maze is a little different to normal. The aim is still to escape the maze, but just like the photon stuck inside the Sun, you don't get to choose which direction you travel in each turn. Instead, the direction that you will go in will be determined by this, a dice. This dice is a little different to normal dice you may have seen. This one has 4 sides. Now, if you don't have a 4-sided dice, don't worry, you can use a normal 6-sided dice. Just remember that if you roll a 5 or a 6, you will have to re-roll the dice. As I am using this 4-sided dice, I am going to go with 1 being move up 1 place, 2 being move right 1 place, 3 move down 1 place, and 4 move left 1 place. If you are using the 6-sided dice, you may want to write down that 5 means roll again, and 6 also means roll again. Once you have your maze and your dice, you will need some kind of counter. I'm using a magnetic pin because my maze is magnetic, so it will hold on to it. But you can use a bead or a coin, whatever will fit inside these boxes will work perfectly. So place your counter in the center box, that's the one highlighted with a white star, and now we will play the game. I got a 3, which means I move my counter 1 position down to the colored box directly below the white star. Now I'm going to put 1 mark in the tally section to indicate I've made 1 move. I pick up my dice and roll it again, and I get another 3. This time though, instead of moving down to the next square, I pass over the white box and stop at the next colored box below the one I was just in. I rolled a 2, so I move to the right, again skipping that white box as there's no particle to bump into there. A 1 means move up, Another 2 means move right. Another 1 and I move up again. A 3. Well, I guess I go back down to where I was in the previous move. Another 3, so I skip the white box and land on the coloured one. We've made it to the edge of the map and we are about to escape. Or are we? Just because you get to the edge of the maze does not mean you have escaped. You've still got to interact with that last particle. It hasn't pushed you in any direction yet. So we need to roll one last time, and that could, if it gave me a 4 or a 1, push me back into the maze and I have to keep playing. I got a 2. That means I escape the maze, as there are no more particles to bump into towards the right. As you can see, the path out was not straightforward, really quite literally. I had to roll the dice 9 times before I managed to escape. It might take you 90 times to escape your maze, or as little as 4. This is what a random walk is like, and it's an important part of what we understand to be happening inside stars. However, it's not just inside the stars that this happens. Anywhere in the universe where there are lots of particles bumping into each other all of the time, each particle will be making a random walk. The image on the back of this maze is taken from a real image of the universe when it was around 380,000 years old. It's called the cosmic microwave background, and it's the last moment in the universe when everything was squashed up so tight that light could hardly move more than a few centimeters before bumping into another particle. After that point in history, the universe expanded just enough to allow light to freely move, and it was able to move for billions of years without bumping into anything at all. Of course, some of that light has bumped into stars and galaxies, and very helpfully into our telescopes, but the majority of the light that was emitted 380,000 years after the Big Bang in the cosmic microwave background has not bumped into anything at all, and it probably never will.